Is Ritesh here, and in this video, as I have talked earlier, that I will be uh, deriving this function, that is sigmoid of x. Sigmoid of x. We know that sigmoid function is denoted as sigmoid of x, and this is 1 upon 1 plus e to the power of minus x. So now we will see what is the differentiation of x with respect to x. What is the differentiation of sigmoid of x with respect to x? So what we will do is we can write this. First we will see, we can write this as 1 plus e to the power minus of x to the power minus 1. Okay, so now what we have to do is we have to differentiate this, and we know that x to the power minus 1 is equals to minus x to the power minus 2. We have to bring the sign of this term here, and then we have to subtract one value here. So using this particular thing, what we will do here is we will write it like this: minus 1 plus e to the power minus x, and the power will increase to minus 2, and we also differentiate x. So what we will do is, once we have done this, we have to differentiate the term inside, and this will be 1 when differentiated with respect to x will become 0 because this is constant, and e to the power minus x, the differentiation of e to the power minus x is e to the power minus x itself, and then we have to differentiate minus x also. So minus x when differentiated with respect to x, we will have a value of minus 1. Is this clear? Or wait, let me make it more clear. Okay, let me make it more clear. So just ignore this. What I will do is, just ignore this. This is sigmoid of x with respect to x. So what we have to do is, we have to first differentiate this particular term, 1 plus e to the power minus of x whole power minus 1. Okay, now when we will solve this, what this will become is, this is minus 1 plus e to the power minus x, and the power has to be increased, so this will become minus 2, or decrease, the power has to be decreased, so this will become minus 2, and then what we have to do is, we have to differentiate the term inside this also, that is 1 plus e to the power minus x. Now this term is solved, so this will be as it is, 1 plus e to the power minus x, and the power is minus 2. Now we have to differentiate this particular term. So differentiating this term is, differentiating constant with respect to x will be 0, and e to the power of minus x is like this, dx e to the power of minus x. Now we will solve this one. So we have to solve this one, so we can write this as, so let me use the next page. Until now we had minus 1 plus e to the power of minus x, this is minus 2, and now we had 0 plus d upon dx e to the power of minus x. We all know that differentiation of this is e to the power of x is e to the power x and d upon dx of x. This is what we have. Okay. Similarly, for when we will differentiate this one, what we will have is, first let me write this term. This is very easy. You all have done this in class 12th or 11th, I think. So now this is differentiation of this. So this will be as it is, and then what we will do is d upon dx of minus x. So this will be minus 1. So this can be written as minus of 1 plus e to the power of minus x, that is minus 4, that is a power of minus 2, and then this will be e to the power minus x multiplied by minus 1. So this minus 1 and this minus 1 will get cancelled, and then what we will have is e to the power of minus x and divided by 1 plus e to the power of minus x. I think this is clear till now. This is whole square. Now what we can do is, we can separate this. How we can separate this is, e to the power minus x can be written as this. We can multiply this by 1, and we can write this as 1 plus e to the power of minus x here, and we can also write this as 1 plus e to the power of minus x, because we have just rearranged this according to our needs. Now what will happen is, see, we don't have to touch this term, because we know that this is sigmoid of x. We know that this is sigmoid of x. We have seen that. So what is sigmoid of x? Sigmoid of x is simply 1 upon 1 plus e to the power minus x. So we have got one sigmoid term. Now we have to just rearrange this. What we can do is, for this particular term, we can write it as e to the power of minus x. We can write it as plus 1 and minus 1. Okay, simple. And what we can do is this is 1 plus e to the power minus x. Now what we can do is we will take this as one term and this is other term, because since the denominator is same, no, we can split on the basis of numerator. What we'll do is write it like this: 1 plus e to the power of minus x divided by 1 plus e to the power of minus x, and then minus of 1 upon 1 plus e to the power of minus x. Now we can cancel this. This will become 1, and this whole term is sigmoid. So now this whole term has been written as 1 minus sigmoid of x, and we have to multiply with sigmoid of x. So let me write it on first page. What we had was e to the power of minus x upon 1 plus e to the power of minus x, and we had in multiplication 1 upon 1 plus e to the power of minus x. We know that this is sigmoid of x. We have arranged it in such a way that we got 1 plus e to the power of minus x and minus 1 divided by 1 plus e to the power of minus x and 1 plus e to the power of minus x. This got cancelled and we got 1 minus sigmoid of x. This whole term is 1 minus sigmoid of x, and we have to multiply this with sigmoid of x. So after this particular derivation, we can say that derivation of sigmoid of x with respect to x will always be equal to sigmoid of x multiplied by 1 minus sigmoid of x. So just remember this, because this will be very handy and we will use this a lot while deriving our optimization equation that we will use to optimize our w. We have this equation, no, this is arg min w star, and we have this whole summation I equals to 1 to n and this whole term here. So we have to find various w's for which this particular thing gives us the minimum value. So while calculating these things, we will use this a lot. So just remember this, and thanks for watching this video, and I will see you in the next video where we will be deriving the optimization equation for our logistic regression equation. Thanks.